Let's see if Christy can. There we go. Now we're live. Okay, good. While everyone was waiting, we're going to give it a few more minutes here before we get started. But more importantly, we have a good Idaho story. So, Doctor, if you were telling me that this summer you were here enjoying my beautiful state on the Middle Fork of the Salmon River and doing some river rafting, and I just asked you right before we went live here where about or why you ended up out here. Was it family or friends? So, continue.
Well, one of my colleagues here in Princeton, New Jersey, said that the Middle Fork of the Salmon River is one of the best and most beautiful sites in the world.
Wow.
To go fly fishing, river rafting. I was there river rafting with my family, my daughter and my nieces, and they had the time of their lives.
Wow.
There are not many people that usually it's like people that will come and enjoy the river and go rafting or go fly fishing. Like I love to go fly fishing. It's usually because there's someone that's here that they'll come and visit and go do it with. So it's rare, that you'll have someone that'll come and visit. So I'm glad you got to enjoy our state. You'll have to come back though and do it. The best times for fly fishing are usually kind of like the spring and fall. Summer's pretty good too. But
I'm coming out then, Terrence. I didn't hear you.
Chris, you have a standing invite, Chris. Come on. You have a standing invite. Listen, we came out to New Jersey, so the least you can do is
we got to reciprocate. We got to reciprocate.
Yeah.
But it's pristine. The water is beautiful and clear, and the trips are so well organized that you can float down the river on your raft for 6-7 days.
I know,
without any barriers. I mean, this is unheard of.
It's huge. If you look like on a map, you can see. I mean, there's a number of rivers that come, but there are some really good fly fishing trips, like drift boat trips that go up beyond like Riggins, which is probably 3 hours north of here, and you can go any further than that and do a drift boat trip. In fact, my brother called me last night from South Carolina, said, "Hey, have you been working on our fly fishing trip for the summer?" Right, and I was like, "Not yet, man." Man, it's just beautiful landscape. It is what you think of the Wild West.
Yes, absolutely, and yeah. So
well, I'm glad you got to come and, like I said, it's rare. So I'm glad you got to come and experience Idaho. And obviously, I can tell that smile on your face isn't fake. So everyone's always welcome to come back. Even though I was joking with you, like, don't go tell everybody because we have a secret here. People.
Yeah, it sounds like a secret society out there. We have to check it
out. People think Idaho is like uninhabitable, which a large part of it is. Not to go through a geography, we'll get started. I know everyone's like, I didn't come here for an Idaho geography lesson. Everybody,
At least we're not talking about home remodeling. Like
I thought about that, Chris, this morning. But the guys just came in to finish patches. So the running joke, guys, so we'll get off Idaho for a second, and then we'll go. When we went out to New Jersey to visit, Chris is back in February, March of this year, and my water heater exploded. Well, our house has been under construction ever since then. God bless the insurance companies; they hold under their dollars tighter than a budget committee at Q4, right? And Chris, they just came in yesterday and did final patch up work, and I'm like, yeah. But anyway, like I said, no one comes to listen to our. I'd rather talk about Idaho than construction work. But anyway, no one came here to listen. So let's jump in, guys. Okay, so the first question I always ask, Chris, but I know it this time. I know the answer. This is our 6th LinkedIn Live event.
This is our 6th and final for 2024.
Yeah, but
we've already got a dozen queued up for 2025, mostly through Q1 into Q2. We've got a bunch of topics already aligned. Our goal is to do one every couple of weeks, every 3 weeks, and there's plenty to talk about. So while this is our last one for 2024, we've got a whole agenda ahead of us for 2025.
Yeah, and the feedback's been great. So I'm glad. And so we have some new. I'm sorry. Go ahead.
No. And I think we were going to say the same thing. So as always, we'd like to bring in our partners on these.
That's what I was going to say. Why don't you introduce our partners from Global IDs and
let me get going on the topic, and then I'll do introductions for our partners.
Good. Okay.
So essentially, we're Rhyno Healthcare Solutions. For those of you who might be joining for the first time, we're a healthcare IT professional service organization that's been around since 2016. I've been in healthcare, myself for 30 years. So that's just a quick introduction on us. We brought in our partners from Global IDs, And they started back in 2001, even before the advent of big data, and they knew what was coming, and they built some great tools in order to help people manage their data and understand their lineages. That's what we're going to spend our time talking about today. We've had two previous LinkedIn Live events on data. The first one was, hey, what do you need to do to start hating your data and start trusting your data and start loving your data? And then we had a follow-up on how do you take that data and do really good storytelling. Well, this time we're going to dive a little bit deeper. And we're going to start talking about data lineage, the tools of data lineage, the importance of data lineage, and how AI is going to impact data lineage tools going forward. So just for a high level, and this is as high as I'm going to go because we've got the experts on the call that can go much deeper than I can. Data lineage is the process of understanding where your data comes from, whether it's internal or external, whether it's created or ingested, and then how it's transformed through the process, and then how it's eventually used for whichever reporting you're using or risk management or whatever the data is used for. It's a critical piece of the data story, because if you can't understand how your data flows, how do you understand any impacts, any changes, and any problems? So we're going to spend a lot of time on this LinkedIn Live talking about what data lineage is, what the advantages are in AI as it comes to data lineage, and then we're going to talk about how this is specific to healthcare. Who we've got with us today is Dr. Arka Mukherjee, who is the CEO of Global IDs. And then we have another Arka on the call. So we're going to refer to, one is Dr. M and the other one is Arka. And Arka is the product manager of Global IDs, and he's going to go into a lot of the detail of the product and more specifically the data lineage importance in the process. So Dr. M, why don't you do a quick introduction of yourself and kind of do an introduction for the team.
Wonderful. Chris, thanks for the opportunity. We are very grateful for the opportunity to participate and to partner with Rhyno. So we are delighted to be here. So Global IDs was founded in 2001, so we are almost on 24 years now. And we've been focusing on this problem of large, complex data ecosystem management. What that means for a healthcare company is that the healthcare ecosystem, which is made up of payers and providers and patients, is a very complex ecosystem which has lots of moving parts. How do you get a holistic understanding of that system? And how do you make sure that it is governed in such a way that it produces reliable, trustworthy results? That's a big problem. We're going to talk about one part of it today, but delighted to be here, Chris. Thank you.
Thank you for your time. Arka S., why don't you tell us a little bit about yourself, please, sir?
Yes, so I'm a solution architect working for Global IDs and for over 20 years. So I've been creating software for data management and data governance with very large data environment, mostly Fortune 50 companies of various domains and industries, including financial services, telecom, and healthcare.
Fantastic. Well, welcome you both. I know we've been working together for several months now, and we've been really enjoying learning about what your company does, what your product does, and how it can support what Rhyno does for its clients when we go in and we do these data programs. So let's first start with the complexity of healthcare data. We always start a little bit here, and then I'm going to ask Dr. M to jump into the complexity of data lineage, and then we'll let Arka jump into the specifics. So, as we've spoken about many times, healthcare data is just growing exponentially ongoing. You've got your EMR data, you've got your claim data, you've got your third-party vendor data, you've got HEDIS data, you've got survey data, you've got pharmacy data, and all these things come together in order to help what is the ultimate goal of improving patient outcomes. Now, this is done in many different ways, and it's funny, we're doing engagement now with one of our clients where we're looking at the operationalization of the whole process from end to end. How does the third-party data come in? How does it internalize? How is the data ingested? How are the reports run? How is roster developed? How is attribution developed? And these are key terms for the ACOs, for the accountable care organizations, to understand how to manage their patients. And it's just an amazingly complicated but important area in which the goal is to have risk-sharing strategies between providers and payers in order to ultimately improve patient outcomes and reduce the cost of healthcare at the same time. So what you have is you have multitude of different types of data sources come in. You have a multitude of data processing that needs to happen. And then you have a lot of validation, reporting, and then obviously compliance. So, all these areas just make it very complicated for the process to run smoothly on a given basis. So the ability to understand where your data comes from and the data lineage of it all and how it processes through the system is critical. I'll talk a little about again. So think a risk management organization where you're sharing data with your accountable care organizations and all the providers on your membership, on their patients. There's conversations that need to happen. There's strategies that need to be developed. What is better for the patient? Are they part of their general provider, or do they need to be part of a specialty care program? This all comes from the data that comes from all these systems. So not only is it a matter of reviewing and sending data to your providers and allowing them to manage their patients, but it's also making decisions from that data that ultimately affect the patients. So these types of operations are critical. And you're talking your data team, your providers, your actuary teams, your risk management teams, your quality teams, they're all involved in this. And each step of the way is something that needs to be generated, calculated, transformed, reported, validated, and then delivered. And you can imagine that there's a lot of different touching points throughout this. So anything that can be done to simplify that process, to make it more reliable, to make it more transparent, is obviously the way we need to go. I was talking to my client earlier this week and talking to their strategy team, and it's not a large enough team, obviously, that and I was going, well, how do you determine where to put your finger? What ACO are you going to work with? What specialty care program are you going to work with? How do you decide which is the biggest profit? And the truth is, there's no playbook for this yet. This is all still new for everybody. Everybody's doing their best to define the program, to define the operations, to define the risks and the rewards, and to find a way to measure all this. So that's why anything that we can do as a company to help our clients to improve that operational process is extremely important. Obviously, within healthcare, then you have other complexities of HIPAA and high tech. Is you need to manage patient data very carefully. This is another reason why understanding where the data is coming from and where it's going to is critical. And realize that this data, again, is coming from multiple sources. It's coming from electronic health records from the providers. It's coming from claim systems within the payer. It's coming from big pharma companies. It's coming from survey companies. It's coming from HEDIS, the companies that create your HEDIS report, which is your performance measurement for health management. All this data is aggregated together, and that just makes the complexity more and more. And it's just going to get bigger. Data is not a problem that's not getting larger. So what I want to do is, Dr. M, why don't you tell us a little bit more about data lineage and the specifics? And I know we're talking about healthcare specifically, but also, you can relate it to other companies as well.
So before we go into the problem of lineage, which is very important, I'll put it in context. Right? So healthcare, of course, in the US is $1 trillion industry and is far from optimized. Right? Our costs in healthcare are going up significantly, and clearly that's a function of the fact that the system is getting more and more complex over time. So what do? Right? We have this complex systems of patients, peers, providers, and of course the pharma companies. And all parts of the system are operating in an inefficient way, both in individual terms as well as in collective terms. So the problem that we are here to address today is to say, how do we actually create visibility into the entire data ecosystem, and how do we create efficiency in that ecosystem? Now, if I had stated that question like maybe 10, 15 years back, I'd be laughed out of the audience here, because this problem is just too large for anyone to bite. But with the advent of AI, this seems to be a tractable problem now. That we can create efficiency in the end-to-end ecosystem through the use of AI. And what's extraordinary about this year in particular is that the Nobel Prize that was given in physics and chemistry relate exactly to this, the recognition that that AI, as the Nobel Prize in Physics was awarded to John Hopfield, and the and my it's a tragedy, but the name is slipping my mind. Is the professor from Toronto, Gregory Hinton? Sorry, Jeff Hinton. Yeah. So Jeff Hinton and John Hopfield are the people who won the prize in physics, who essentially uh, uh, showed that AI has the ability to solve very large, very complex problems way beyond what humans can. And then the other three Nobel laureates in chemistry, John Jumper, David Baker, and Demis Hassabis from DeepMind, uh, solved a very complex AI problem called the protein folding problem, which essentially opens up all of biology to computational modeling. So we find ourselves in a very, very extraordinary time for health and healthcare. And the Nobel Prizes are a recognition of this fact. So, with that said, how does AI actually come in, and how do does it help understand this whole ecosystem? Um, we are going to talk about the governance of the ecosystem and the problem of data lineage. But before we actually jump into that, let's just think about how do, for example, how does the what are the problems that the peers are trying to solve with AI? And I'll just point to a few, and then I'll point to a few use cases that the providers are trying to solve with AI. And then, with that context, I think we can jump into the problem of governance and see how all of this makes sense. So, of course, the Gartner has published a bunch of research on this. But if you look at the idea of what are the peers trying to do, the peers are essentially trying to make sure that plan enrollment is happening through AI, and that as we go through this complex process of plan enrollment, different parts of it, AI is brought into it in order to create clarity into the process and reduce the complexity. There are AI assistants for creating, helping build the contracts, and then there's of course um, the payers are also using code generation using AI to optimize their systems. But that's just the tip of the iceberg. There are at least 15, 20 sort of use cases that the peers are trying to do now. And in contrast, so those seem to be more aligned in terms of the interaction of peers with patients, those use cases. But for the providers, uh, the core use cases are really oriented around value and cost. Right? So, how do I find improve data accuracy, reliability, and transparency into my systems? Uh, and because the cost of those systems and the complexity of those systems is very high. There's issues of data quality, there's issues of privacy, security, regulation, all these things that are that the providers are then saying, we can use AI to optimize these systems. So you get a sense of here, AI is going to be used universally, both by peers and providers, in order to optimize their systems. And now we come to the heart of the problem that we are going to talk about today, which is I need to govern the whole system. This complex system, which has tremendous amounts of data floating in and out of it, you know, is beyond the comprehension of any single human. Right? It is a very large problem, and this is perfect for AI to solve because AI can take different components of the ecosystem and handle it in very efficient ways. So governing the whole ecosystem is what Global IDs has been working on for the last 20 years. And our approach is to say we would like to understand the whole ecosystem and we'd like to bring automation into the whole ecosystem so that there's less manual work and more automation, and AI is our vehicle more recently in terms of doing it. We've been working with large, healthcare companies, United Healthcare and the like, and a lot of the Scripps company, Express Scripts, All Scripts, etc., and many of the pharma companies as well, Merck, Bristol Myers Squibb, etc. And we've had the privilege of looking at these systems in gory detail and understanding sort of the links that connect everything together.
And glory is the right word. Glory is actually the great adjective.
That gives you a little bit of the context of why we are at this special point in time, how AI can potentially improve the whole ecosystem, and why we have a little qualification in at least knowing how this system operates at scale, and potentially how to fix it.
Dr. N, can I ask a question real quick? And again, you invite the dumb guy in the room, which is me, because I like to basically get and understand things. We talk a lot about data, and data lineage is a term that I haven't really heard. And I know you've just talked about it and weaved it in there and talking about AI, but maybe if you can help for the dumb guy in the room, take a step back and kind of
let's dive into the details. Arka, why don't you take us through some data lineage?
Yeah, that would be great.
So we'll go into it in a moment, but Terence, no dumb questions here.
Okay,
right?
good. All right, good.
It's a fundamental question that you're asking.
Okay.
And while we are talking about lineage, we should say governance and lineage, right? So it's really, how do I govern the whole ecosystem? How do I put all the checks and balances in place as the claim system really connects, or the transactions associated with claims connect the payer, the provider, and the patient together in this ecosystem? How do I govern that entire flow of information? So now, of course, companies, everybody's sort of been working on this for the last, who knows how many decades, right? So why is this a new problem, right? Well, it's not a new problem, but it's just the complexity of the system is going up, but the role of automation is becoming more and more important, because as costs keep going up, we need to bring automation to bring the costs down. So governance in the past has always been about static data, right? It has been data in one place at one time, right? Lineage is a new way of looking at it, because this is about dynamic data. It's not just data sitting in single databases. It's the data that flows from system to system, right? That is new, and it's finally the computational power of these large language models that allow us to sort of solve this problem holistically. So that's why lineage is new. Governance is old. Lineage is new. But Arka, please now start talking about the problem of lineage itself and how potentially it can help resolve the complexity of the ecosystem.
And just 1 second before you start, Arka. So Terence, we got to mark 1018 as the first time we used the word governance. I know we.
That's a record. That's a record, Chris.
Governance coming to the conversation, and this is a record. 18 minutes into it. Arka, please educate us.
Right. So in simple terms, data lineage refers to tracking and visualization of data as it moves through various systems in your organization, from the origin of data, where it is first inserted in some system, to the final destination, which is a reporting system or an analysis system. So it should show how data moves through all of these systems and is transformed and possibly even accessed across all of these systems. So it essentially can be at different levels. So you can do it for an entity, like let's say a patient or a payer or a claim, see how claims data is moving across systems. Or you can construct a map across the physical metadata. So see how data is moving across tables or files, or what data is moving from system A to system B. You want to see all of it. So it provides you data traceability And if we are looking at it from the angle of downstream systems like reporting systems, it provides you data provenance. So you should be able to go inside a report and look at a field and have some mechanism telling you where the data is coming from. So sorry, go ahead.
So if I can jump in, Terence, to use your analogy from Idaho, right? Think about this as how a river gets created. You have a whole bunch of tributaries, in this case, flowing from patients, from the payers, the providers, right? All these tributaries are sort of joining a bigger stream, and then a bigger stream is joining a river, right? So lineage is the flow of data in this river of data, starting with tributaries, you have bigger streams, and then ultimately the river leading to the ocean itself. That is what, if you think about that picture, then you understand what lineage is for data. It's just data flowing as opposed to water flowing. Yeah.
Dr. M, I never thought I'd hear an analogy brought in from an Idaho river, but I love it. That actually helped me, but obviously, conceptualize images. So continue.
Continue, please. Yeah.
Yeah. So before we go into the quote unquote gory details of how we find lineage, the three concrete results that it usually brings in all industries is transparency, compliance, and data quality. So transparency in terms of understanding how the data flows across systems or where a data in the final reporting system or analysis system is coming from. So it's basically a way of validating the output in the final reporting systems by tracing the flow backwards. Then you have quality. And basically for all data quality problems, it is important to understand the root cause of that quality issue. What is the underlying issue and where is the upstream system from where the quality problem starts. So if you see an error in a downstream system, one approach is to fix the error there. The other approach is to find out where the error originates from, track back and fix the error in the upstream system. So that's an important function of finding data lineage, an important result of finding data lineage. And finally, compliance, regulatory compliance. So you have compliances like HIPAA and CMS that requires organizations to track where PHI is accessed or modified or used or shared. So lineage shows the flow of these sensitive information across systems, from source to various intermediate storage systems and reporting endpoints. So that gives you some control over how these things are stored or accessed. And if you realize that these things are stored in places where they shouldn't be stored, or they're replicated in systems which is basically redundant, then you have extra points of risk. So this provides you a mechanism of risk mitigation by finding out how your sensitive information is flowing through systems. And eventually it makes you more audit ready for these regulatory compliance measures.
So
I was just going to say, so just bring us back to the operations we were talking about earlier. There's a whole process where these reports have to go out on a monthly basis to the ACOs on patient roster, patient attribution, all the claims data, all the financial data, all the clinical data. And what I see happening as the biggest delay in the operational process is exactly what you said. A result comes out and they can't figure out why the attribution was decreased this month in a certain ACO. And it takes them 2 days for somebody to go back and figure it out. So it sounds like data lineage, understanding all that will help to improve that turnaround time, answer those questions quicker, and therefore be able to deliver everything in a timely fashion.
Absolutely, Chris. So I mean, let's take a sort of real world example, right? Let's say by some unfortunate reason we land up in the hospital and the hospital files a claim, right, with 10 ICD codes, yeah, under the claim, and yeah, some of it is denied, right, and then an adjudication process starts, right. The problem is it's very hard to sort of understand where in the process, yeah, there was a quality problem that led to that denial, right? And so it could be that the ICD code was fat fingered and the wrong ICD code was put in, right, and was not related to the treatment. But because there are tens, maybe hundreds of systems in between the claim submission and the actual arrival at the peers systems, we don't know where along the way something has gone wrong, but it has led to this delay in the claim being paid. So that issue that that when things go right, everything is great,
Right.
but when things go wrong, it is a nightmare to find what happened in all these systems along the way that prevented the claim from being paid. So that's where lineage comes in, because lineage and quality comes in, because along the way, if the quality of the claim degrades, right, or the parts of the claim that are flowing through degrades, you have a big problem, right? Because a significant portion of your claim may not be paid. So that's an example of where lineage comes in. It's all these threads of the tributary, right, that are going through the system, and there's quality problems. There's pollution on the in the river, and the forensics of figuring out what's actually happening is where AI comes in, because it can solve these problems at scale and with the right level of granularity. Yeah. So
Well said.
yeah, please, Arcus, go on.
Yeah, so that's those are the real uses of lineage in healthcare industry. Now we can possibly start discussing how we do it, or at least how we do it inside global IDs. So
Please.
there are, yes, and so this used to be quite different before the advent of AI. And while human validation of the results of lineage is still necessary, it would be much more time consuming if we were not being assisted by AI here. So to find out this map across systems, there are two primary approaches. One is to look at the data itself. So we use AI and machine learning to cluster similar information together based on their patterns or distribution of values and so on. And then we have a much simpler problem in hand. So if we understand that across systems, these are the patient identifiers or these are the ICD codes, then it's a matter of finding out the directionality of a flow, which can be detected through timestamps in various tables and so on. So there is this approach of looking at data itself, clustering the data together, and finding out lineage from the data. And there is also another approach of looking at assistive documentation or code or ETL scripts. So every organization has a bunch of ETL tools, which has ETL scripts inside of that. There is code.
Explain ETL for the audience real quickly, just to make sure.
Extract, transform, and load basically refers to a software or a script that moves data from one database or one system or one file to another database system or file.
Thank you.
It could also be done through like code, like let's say Java code.
Yep.
It could be also be done through stored procedures, which are basically snippets of code that exist within database. We may also have to look at structures of reports. So let's say you have a Power BI report at the end of the flow. So it's necessary to tie in that structure of report with the overall ETL flow. AI has made it much simpler to actually ingest all of these myriad pieces of technical information, ETL, code, stored procedures, report structures, inside the software, and understand the mapping from that. So we can find the mapping from the data, we can find the mapping from all of this technical information that already exists within the software. And again, it's a completely different speed and level of automation after the coming of AI.
So, if I can add a little bit more color to that, Terence, tell me if I'm on the right path or others reeling me
No,
back.
you're good. I was just going to kind of ask. I think let me ask this, and then you can kind of take it, or maybe Arka as well, right? Which is, and you started talking about, AI, and I don't even know the word that you used in terms of how it interacts right now with data lineage. And for the dumb guy question, my question is like, hey, has AI? Do you see AI improving the data lineage process, supporting it, however it may be, or like what are some of the, and a secondary question is like, hey, what are some of the key applications in healthcare? And I know there's a lot there, but just for the dumb guy, slow it down a little for me.
Remember, in this whole complex equation, we are all dumb guys.
No, you got this is great. I love this, and again, especially when it comes to the AI and lineage, these are two concepts. The AI is just obviously being talked about substantially in all marketplaces, and now with data lineage, I want to understand. I want to really get a good understanding of that. So,
Yeah. So I think the comment or the color that I wanted to add to what Arka S was saying was, there are like two fundamental or two or three sort of fundamental technical problems, right? One is the problem of master data management, right? And so the three are master data management, the transaction flow management, let's say the claims process, that part, and then really understanding the ETL and the integration of data across these systems. So there are three fundamental problems. The master data problem, which is uh, many of these provider organizations don't have good master data there. And so, like, I go into a hospital, and I've been to the hospital before, but they don't have my record for my name and my identity in one place and linked together. They have multiple records. And so no one can correlate my health history. No one can correlate sort of what happened in the hospital the last time around. That kind of thing. This is a problem where my data is in 100 different places as opposed to being in one place. And so master data management essentially deals with that. And there are many different variations. What I just talked about was the patient master, but you can have similar problems that the provider. Uh,
Yes.
yeah.
Provider data management isn't handled well in many organizations across the board.
Yeah. In fact, most organizations, including the large organizations we've been to, have real serious problems in terms of handling master data. So it has to be put in one place, and that place, the master data, has to be relied and trusted. And most healthcare organizations can't provide that guarantee, right? Because too much stuff is flowing in too fast. So one is this problem of master data management and making sure that all our records in the healthcare system have global identifiers associated with them. And so our company, Global IDs, essentially make sure that we have common identifiers and unified identifiers that allow us to be sort of referred in singular ways as opposed to multiple ways. This is difficult given that HIPAA is in there. It's difficult to take information from different providers and create it, but nevertheless, that is the heart of the problem. The second problem is then just understanding the transaction. So there are different transactions that are flowing through the system. The main one being the claims management, right? And so transaction data flow is one where it relies on accurate master data so that these transactions can flow properly. But the master data, if it's off, then the transaction itself will be problematic, right? So the transaction data flow, and then the third part is sort of handling the quality of this flow, the operational data quality of this flow, as it sort of moves across the river, so as to say, right? So these are the sort of big chunks of problems that need to be handled by the AI. There are other parts of the AI. There could be contracts and documents that the AI needs to read by itself and then put it into the structured data system in the river. And so a lot of that low hanging fruit related to taking contracts, getting the AI to read it and structure it and putting it into the system is what is happening right now. So I think, yeah, I mean, those are the 3 or 4 sort of rough areas where AI can make a huge difference, right, in improving the overall visibility and clarity in the ecosystem.
So,
Chris, your comments? You have
no,
vast
I
experience.
agree with everything you're saying, and just for the sake of time, we're 40 minutes into this conversation, and I think this conversation can probably go for quite some time.
Yeah.
Why don't we start talking about some real world examples? Arka, I believe you brought some details to kind of highlight this. Can we maybe move to that?
Yes. So basically, as Dr. Mukherjee was saying, that what we do in a typical healthcare environment is first um, try to automatically catalog all authoritative data sources, all master data sources, and map them with each other based on data commonality. And then we try to demonstrate the understanding of lineage across those master data sources. One new and upcoming area that we are very interested in and working with is at the conjunction of master data management and data lineage is something called knowledge graph. So once you have master data across different data environments mapped with each other, you can actually create a graph out of that master data. Let's say you have a patient, you have a provider, and its data is spread across different systems, files, etc. Once you have a map, it should be possible to pull it all together in a graph which shows the entire history of that patient, all the various diagnoses, where he has been admitted and so on, and the various claims and adjudications and so on. So it's the entire master data of the patient. It's difficult to store it in any tabular form, but it can be stored in graph. And if, as a result of lineage, we get up to this point, then it is possible to ask that graph anything about that patient, which may be spread across 6 or 7 different sources, but the graph should be able to answer us that. This has implications across everything. I mean, quality, compliance, the example that you were saying earlier, that finding out the root cause of an error downstream, etc. So that's we are very excited about that.
So Terence, yeah, my dumb question in all this is, when we talk about graphs, are we talking about graph paper or something else? so, so to answer the question myself, yeah. So these things called knowledge graphs are becoming the way in which AI can operate very, very efficiently. Yeah, they're called, yeah, graph AIs, which essentially, the graphs are a mathematical technique that connects all information together, right? And it can be done at a very, very massive scale. So what Arcais is essentially saying is, what Global IDs does is takes all the information derived through the lineage and construct a knowledge graph out of it, right? And with this knowledge graph, all the problems that we are talking about, quality, integration, privacy, governance, just question and answer, all of it can be addressed by the knowledge graph, with no ambiguity or very little ambiguity, right? So essentially, the solution to the problem of governance and lineage is a knowledge graph. Arcas, do you have any kind of, can you show it?
No, I don't have that ready.
Okay, all right. But like maybe a slide or something like that shows what a knowledge graph looks like might create some clarity if you have that. Or if not, Chris, we can provide it to
Yes.
any one of your audience who wants to know more.
Yeah, we can have follow up for it for sure. I mean, we'll have the comment sections, and we can always add more information in afterwards if necessary.
Absolutely. Yeah. Okay. So proceed, please.
So like I was saying, that if you have these capabilities, and if these capabilities are combined with other capabilities, I'll give you an example. If you have a software that has data quality analysis, and data cleansing capabilities and lineage within the same umbrella. So you should be able to see a data quality issue, detect a data quality issue based on rules that you have put in uh, uh, the reporting system or the analytics system. Through the lineage capability, you should be able to track where that data quality problem arose. And if then you have data cleansing capabilities, then you have some way to remedy that data quality problem as well. So while it is important to understand lineage, lineage by itself just gives you knowledge of how the data is flowing. You have to do something about it. You have to maybe revoke someone's access from a PHI, a set of PHI data. You have to solve a data quality problem. You have to provide a report of why the data in the report is the way it is. So those capabilities in a lineage software are important as well, which we do have.
That's really important, as you said, because all those pieces, there's a lot of players in this, especially when you're talking about risk data, shared risk between providers, payers, and ACOs, and all this type of stuff. And there's a lot of back and forth, and there's a lot of appeals, and there's a lot of questions, and the ability to take the data from the lineage into the knowledge graph and be able to answer those quickly is what's going to help people to operationalize. What I'm finding from our clients continually is they're so focused on delivery. They're so focused on getting it out the door because they're not meeting their deadlines, they're not meeting their contractual obligations. And then there's all the back and forth on what's the quality, what's the appeal process, what's the back and forth between the ACOs and the payers. So to your point, anything that can be done to help answer those questions quickly, to build confidence, to build credibility, to build transparency, obviously will help the process along the way.
Chris, can I ask you something? Like, what are some of the key applications that are in this AI guided lineage with respect to healthcare?
Well, I mean, ultimately, the biggest ones we see are on these shared risk programs. I mean, anything that if you take a payer organization, again, they have multiple sources of data coming into them. They've got their own claim system, which has a huge amount of data. They've got other internal systems that they feed. They've got care management systems that they need to update. They've got all these processes that go into their day-to-day operations. And then they get all this data from the outside, whether it's from a pharma company or whether it's from a survey company or whether it's from a HEDIS company, and they have to bring it all together. So again, the application itself, to me, at least what we see mostly, are value programs. How do you bring value into medicine? How do you turn medical care from pay for services to pay for performance? And the only way that you do that is with real data across all these streams and being able to provide them in a real-time fashion with confidence, with transparency, and with the ability to act. So it's 10:45. We got about 15 minutes left. Do we have any slides we want to share with the audience? Do we have anything we want to show them about the application?
I think I can go into the application for a little while and show how the output
Let's
looks.
do that. Let's go into the application and show them around, and then I think that's going to bring us to wrap up. So that's great. Thank you.
All right. Okay. So I'll.
But while Arka is pulling that up, Terrence, to answer your question, there are multitudes. I mean, we're talking one specific value program is one specific data solution. There are multitudes of data needs throughout the healthcare organization that all have the same value, the same risk, and the same issues.
So am I sharing my screen now?
Yes. Yep.
So before going into the other parts of lineage and how it is found, etc., this is a sample technical output of lineage. So where we are basically looking at data flowing between different systems. So these are different healthcare systems in a demo environment. And we have patient data flowing across these different systems. And the software goes and identifies that by looking at the data values. So the actual physical names here are all different. And the software here, at least, it identifies that some data values have changed while going through that flow. So that's a kind of sample output that we have inside the software. These could be, although not necessarily, data quality errors. And by showing this, you can actually track back and understand which particular system this data quality error arose in, maybe over here. Till here it was something else, and here it has changed to something else. So this is a granular level output. At a higher level, we see things like this. So this is a data flow diagram where data is moving from one system to the other. Some of these are source systems, some of these are reporting systems. And if we go into one of these systems, it leads us to a more complex diagram, and this will require some explaining, so I will not go into the details, but it takes us to a more complex diagram where it shows how data is moving between different tables or different files. There could be transformations along the way. So these small icons here are transformations, and this tells us that data was moved from a certain table to another table, and there's a transformation in between. So for example, here is a piece of code that was used for that transformation. So it's eventually, if you drill down, it can be fairly complex, but you can look at whatever level you want to look at it. So you can understand how data is flowing across systems, or how data corresponding to a certain entity, such as a patient or a pair, is flowing across the system. And you can go into details and inspect various things, such as these data quality errors.
So if I can add my overlay to that, Terence, so what you're seeing over here is drops of water, right, as they are going down the tributary into the river, right? The picture that was shown earlier looks like a river. So just so this is sort of one drop of water, right, heading down the tributary into the river. So we have the ability to see all the drops of water as they are flowing down the tributary, and this gives us the ability to do forensics when something goes wrong, right? Because we see the whole river. In the language that, hey, we see the both the forest as well as the trees in this very complex environment by using these computational techniques brought together by the AI, right? So and yeah, so this, I think, gives a visual representation of what we do, and it allows us to create the transparency, traceability, and trust in the entire data ecosystem. So
So
If you had something like this for fly fishing, it would be great. Not to get off track, but this actually helps me understand. I really appreciate both the analogy you're drawing as well as the imagery. But
well, it's the practicality of it all. I mean, obviously, being able to look at data from here and what Arka has just shown from left to right, and seeing where the data transformed and seeing where the error happened. I mean, that instantaneously gives you where to look, and to show the code that actually transformed the data. Very valuable. Otherwise, you're talking to multiple developers, multiple data people. This can take days to potentially troubleshoot, where you can troubleshoot it in minutes. And that's key, because again, when we talk about these things are timely pieces of data. They can't just sit there and then they regenerate each month. So they have to be month over month over month over month. So to be able to dive in at this level is just going to be critical. Now I got a question for you. So obviously this is living and breathing. This isn't one and done. This is start somewhere and grow and grow and grow. What does it take to implement something like this to get your first set of data lineage transparencies?
Dr. Mukherjee, you are taking that, or should I answer?
I can take it. So we are essentially saying that what the software needs really is access to the underlying systems, right? That is the rest. Most of the work is actually just getting access to these systems, and yeah, we can understandably, both the providers as well as the peers are very reluctant to let software vendors into their systems. But we've worked with vendors. We've established that we have the right level of security, and we have de-identification, and we are careful about privacy and regulatory compliance. So once that is done and access is given, most of the remaining tasks are automated. Right. So we're talking essentially in terms of maybe weeks to connect to the actual underlying systems, and then maybe you're saying within 3 months you'd have a lineage diagram, not necessarily the whole lineage diagram, not necessarily the whole river, but at least a significant part of the river. Right.
Well, and the way I look at this is one of those proof and then grow. So you do a use case, you pick a particular one, you show that, and within a couple of months, once you show that value, I mean, and you open that up to the audience, I'm sure that it is flooded with let's do this, let's do this, let's do this. There is so much opportunity once they see what the value is. So again, speed to implementation is always critical to show that initial value. Once you do, then you can just grow from there organically.
That's right, and this is particularly important because I think Chris, correct me if I'm wrong, but typically it takes somewhere between 90 and 180 days to get a claim paid. Yeah, I mean that's a lot of time,
Yep.
right? And so anything that can be done to speed up the whole process and green light, certain flows, and red light certain flows, and yellow light certain flows, right, is very crucial to getting the claims paid much faster.
Well, and I'll even give you another real world example. There was an example where again let's talk about provider data for a second. So one of the key things in a value program is to understand your roster. Who are your ACOs? What providers are under those ACOs? And then who attributes the members to those ACOs to the attribution. Being able to understand problems with the data. There was an example where there was a problem with the member rosters through the source system. The gold standard system was wrong. It was feeding wrong downstream. They didn't find it for 5 or 6 months, and then they had to go back and rerun the data for the entire cycle.
Mhm.
So it brought problems with credibility. It brought financial implications. It brought patient implications, and again, it caused all kinds of upstream and downstream impact just from not being able to see this. And again, so I can see if you can find this quickly, if you can look at the lineage, if there's ways to validate the data along the way through this process, I can only see it improving the overall performance.
Yeah.
All right. Anything else to cover, gentlemen? It's 10:55. We got about 5 more minutes. Again, I think we can probably talk for another hour easily, but everyone's getting ready to go on the holidays and enjoy themselves. So let's see if we can wrap up in the next few. Dr. M, any last thoughts on your side?
Well, I think without a doubt, and I'm not the only one who's saying this, is all the participants of the healthcare system should at least dip their toes in the water and say, what can AI do for me? Right? Because it seems that what the research is showing is that unlike the popular way of thinking about AI, that AI is going to take away our jobs, right? In healthcare, that doesn't seem to be the case. None of the healthcare companies seem to regard AI as a mechanism of reducing staff. Instead, I think the idea is that we'll use AI to uplift our workforce and upgrade our workforce, and that the people who have expertise still can bring a lot of expertise to the whole chain, but AI can take the grunt work over, right?
Yeah.
So I think anyone who's sort of involved in this ecosystem should at least learn how to use AI-based use cases in order to create more efficiency and more value in their processes.
I excellently said. Arka, any last thoughts from you?
Yes, so I just in addition to what Dr. Mukherjee has just said, that lineage can be looked at as an operational use case. Even after you establish the initial lineage diagram, a lot of changes keep on happening in the data environment. New records come in, of course, but the structure and the content of the data repositories also keep changing. So now, more than ever, we have a way of automating that with AI. We can catch these changes, and we can keep changing the lineage understanding with the aid of AI, because that lessens the human activity that you need to find out lineage.
Well, and I just want to jump in, Chris, and say I like we started this conversation right with the Idaho River, Dr. M being able to enjoy it, and it really that analogy has really helped me understand the data lineage process, the flow, that you're talking about the drops of water. I mean, and feel free to now leverage the dumb guy in Idaho and use that analogy, guys, moving forward, because it was really helpful.
It's ingrained in my mind right now. So again, we want to take this time to thank everybody for joining us. We want to thank Dr. M and Arka for your expertise. Really appreciated. A little call to action here. If anybody's interested in learning more, please just reach out to us in the comments. We can discuss your data challenges. We can discuss how Global IDs maybe can help support those. We can discuss more about data lineage or storytelling or how to start loving your data, any of those. So please feel free to put comments into the LinkedIn when it's posted in this afternoon. Otherwise, we'd just like to take some time to wish everybody a happy holidays, wonderful, healthy, and happy New Year's, and a very prosperous 2025. Please keep your eyes open. We'll be joining again in mid-January for the next LinkedIn Live event. Thank you all. Have a great day.
Thanks, guys.
Happy holidays.
Happy holiday. Yeah.
Thank you.
Take care.